Good day, my wonderful scholar. Welcome to the online class. I will be your physics tutor for today. My name is remain WAEC, and our topic for today will be derivation of equation of motion, where we'll be looking at the basic definitions, derivation of equation of linear motion, the application of the equations, then motion under gravity. Now, to start with, when we talk about derivation of equation of motion, from our concept of motion itself, motion simply is what? A change in position as a result of what? An external body. So under this basic definition, we'll be looking at the following. 1, distance. 2, displacement. 3, speed. 4, velocity. Then 5, we'll be looking at acceleration. And under this acceleration, we have also deceleration or retardation. Deceleration or retardation. So starting with the first one, distance. What is distance? Distance simply means what? The portion covered as a result of what? As a result of movement from one position or from one location to another location. For example, if you have two bodies, little points A and point B, then the space between these two bodies, the space between this body is all referred to as what? As distance. So you can say distance is what? The space covered between two or more bodies. Why displacement is what? Is the distance covered in a specified direction. I repeat, displacement is the distance covered in a specified direction. So what you cannot ask, what is the difference between distance and displacement? Yes, distance we say is the space covered between 2 points. But displacement is what? The distance covered in a specified direction. Let's look at the difference between the two. For example, if I say a boy travels a distance of 10 kilometers, a boy travels a distance of 10 kilometers. And in another breath, I said a boy travels a distance of 10 kilometers due south. Now, these two, if I'm to sketch these two problems, for the first one, a boy travels a distance of 10 kilometers. I did not tell you whether it is to the north or to the south, to the west or to the east. So that is why we said distance is what? Is just what? A space in region between two bodies. So a distance of two bodies, the boy can travel a distance of 10 kilometers either this way or this way or this way or this way, because I did not specify the direction. And all of them is still what? 10 kilometers, 10 kilometers. But for the second one, we say a boy travels a distance of 10 kilometers due south. From our cardinal points, now we have 4 cardinal points: North Pole, South Pole, West Pole, and East Pole. So since I say a boy travels a distance of 10 kilometers due south, it means the 10 kilometers will be what? On the southern part of the cardinal point. And that is the difference between what? Distance and displacement. Also, the distance is a scalar quantity, while displacement is a vector quantity. When it's a vector quantity, any quantity that has both magnitude as well as direction. Let's move to the third concept, which is speed. What is speed? We define speed with respect to what? To distance. As you all know, that if you look at any car or any vehicle, there is what called the speedometer. And what is the function of the speedometer? The speedometer what? Takes what? The reading of the distance covered within a particular time interval. So that will now take us to the definition of speed. So we define the speed as what? The distance covered in the specific, the distance covered with respect to what? With respect to time. That is, our speed is defined as what? Distance traveled all over what? The time taken. Distance traveled over time taken, which we can express as S is equals to, speed is equals to what? Distance over time. So speed is also what? A scalar quantity. And the unit is the standard unit for speed should be kilometer per hour. But in most contexts, they still use as what? They use meters per second. But the standard unit for speed is kilometer per hour. So, and it's also what? A scalar quantity. That takes us to velocity. So we define velocity with regards to displacement, and we define speed with respect to what? Distance. So based on the definition of displacement, then we'll go to velocity. So we define velocity as the rate of change of displacement. If somebody give us that velocity is the rate of change of displacement, that is okay. But to make it full, you can say velocity is the what? The rate of displacement with time in a specified direction. The rate of what? Displacement with time. That is, our velocity is equal to what? Displacement all over what? Time taken. Which mathematically we have velocity is equal to displacement s over time. So you can see the difference between the two. So the unit, the SI unit, which is called standard unit for our velocity, is what? Meters per seconds. Or you write it as ms raised to minus 1. It's the same thing. And velocity is what? A vector quantity. Let's move to the next concept, which is what? Acceleration. What do you mean by acceleration? Acceleration can be defined with respect to what? Velocity and time. It's just like you are driving a car, and when they ask you to what? Accelerate. Accelerate means what? You put your leg on the throttle and what? You raise it. Then when they ask you to stop, you what? You stop, you remove your leg. So the meaning of acceleration is what? To increase the speed with which what? With which you move. So we define acceleration as the rate of change of velocity with time. The rate of change of velocity with time. That is, mathematically, our acceleration is equal to what? Change in velocity divided by change in time. Change in time. Which we represent acceleration with letter A. That is, acceleration A is equal to change in velocity over change in time. If you remember from your basic calculus, which is what? Mathematics or further mathematics, this change in velocity over time can represent as what? Delta V over delta T, or dV over dt. So change, when you say change, it means you are comparing two things. So invariably here, we can write our acceleration A as what? V minus U over T, where V here stands for the final velocity, U stands for the initial velocity, that is the starting velocity, and T stands for what? Our time. We'll still make use of this expression. That is VA acceleration A is equal to V minus U all over T. We still come back to that as expression. So the opposite of acceleration is what we call deceleration or retardation. Accelerate means move forward. Decelerate means what? Move or reverse, to move backward. So deceleration is just what? A negative acceleration. Let's now move to the other concept, which is what? The derivation of equation of motion. Now, to derive the equation of motion, it is based on these definitions that we have what? Highlighted above. Now, assuming a body starts from rest, let's say a body starts from rest, that means the initial velocity, u, with initial velocity u, are you with me? And travels with a velocity v in a specified direction with acceleration a and in a time t. These four parameters can be combined to give us what we call our first equation of motion. From our definition of acceleration, we said acceleration A is equal to change in velocity over change in time. That is, A is equal to V minus U all over T. From these parameters, if we cross multiply, then we are going to have what? 1 into V minus U, or let's say A times T is equal to 1 into V minus U. Invariably, we can say AT is equal to V minus U, or V minus U is equal to AT. So therefore, our velocity is equal to what? U plus AT. This is our equation 1 of motion. and that is what we call the equation 1 of motion. What we are the motion we are talking about is what? Linear motion, because we have different types of motion. What we are dealing with is what? Linear motion. So this is equation 1 of what? Of motion. V is equals to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken. Now, to get the other equation of motion, we have 4 equations of motion, linear motion. To get the second one, let's say we define average. In mathematics, when you say average, it means what? You are adding either 2 or more things and divided by the numbers of appearance. So let's say the average velocity. The average velocity, v bar, is equal to what? V plus u divided by 2. Average velocity is equal to what? The final velocity plus the initial velocity divided by 2. And we also know that we define our displacement S is equal to what? Displacement S of speed. Velocity V is equal to what? S is equal to V plus U over T over 2 bracket T. Also, we have this formula that our what? Displacement or the distance covered is equal to what? The final velocity plus the initial velocity times what? Over 2 times what? Times T. Based on our formula that what? We said what? S speed is equal to V over T. That is, we said what? Velocity is equal to what? Displacement over time. Then it means that displacement is equal to what? Velocity times time. So we can define this as what? Average velocity, displacement here is equal to what? The average velocity times time. That leads us to Vs is equal to V plus U over 2 into bracket T. Let's call this equation 2. Now, if you now incorporate by making T the subject of formula in equation 1, if you make T the subject of formula in equation 1, it means we are going to have, from equation 1, we have V minus U is equal to AT. Then make T the subject of formula. It means we have T is equal to what? V minus U all over A. Now, let's substitute this equation, which I can call, let's say, equation X, into a what? Into this equation 2. That is, anywhere you see time in this equation 2, you replace it with what? V minus U over T. So, continue from this formula, it means we have our S is equals to V plus U divided by 2 times, what's our time there? V minus U divided by A. So if you expand the bracket from what you have here, it means we are going to have what? S is equal to what? V plus U into V minus U divided by what? 2A. Then, if you look at what we have here, this expression I have is what we call difference of 2 squares. Difference of 2 squares simply is that if we have A squared minus B squared, then it's going to give us what? A minus U into A minus B into what? A plus B. So if following what the expression above, which we call difference of 2 squares, then it means that our S here is going to be what? V squared minus U squared divided by 2A. Let's say this is over 1. If you cross multiply this expression, it's going to give us what? V squared minus U squared is equal to what? 2AS. And invariably, therefore, our V squared is equal to U squared plus 2AS. This is equation 3 of motion. So a recap, quickly. We said equation 1 of motion is what? V is equal to U plus AT. Equation 2, we have S is equal to V plus U over 2 into T. That is, from our average velocity, we have our S is equal to average velocity times time. Then we said equation 3 is what? V squared is equal to U squared plus 2AS. To now get the fourth equation of motion, we are going to capitalize on equation 1 of motion, which is this. By what? By squaring the expression on both sides. That is from equation 1. From equation 1 of motion, we state that what? Our V minus V is equals to U plus AT. If you transfer this to the other, you have v minus u all squared is equals to at all squared. And this will give us, by expansion, v minus u all squared will give us v minus u into v minus u is equals to a squared t squared. So when you expand this, v times u give us v squared. V times u, that's minus 2uv. Then u times u plus what? U squared is equals to what? A squared plus t squared. So invariably following that, from that expression, we have v squared is equals to what? V squared minus 2uv plus u squared is equals to a squared plus a squared and t squared. So we can do a kind of what? Factorization from this expression because of what we have here. So from what we have here, if you transfer this to the other side, we are going to have what? V squared is equals to 2uv plus u squared minus u squared plus what? A squared t squared, which means we have v squared is equals to, factorize the expression there, we have u common, u into 2v minus u plus a squared t squared. Now, coming back to this equation here, which we say we have v squared minus v squared is equals to u squared plus 2as. We want to get the third equation of motion. So from what we have here, we have our s is equals to ut plus half at squared. By substituting which equation now? By substituting this equation v squared minus u squared into this expression, that leads us to what? The third equation of motion. That is from v squared plus u squared, which we want to have here. So by substituting, that will give us equation 3 of motion. So equation 4 rather. So these are the 4 equations of motion where S stand for. So let me quickly write them out. The 4 equations of motion that we have in physics, which are linear motion. The 4 linear equations of motion as derived above. The first one is V is equals to U plus AT. Then the second equation is S is equals to U plus V over 2 bracket T. Then the third one is V squared is equals to U squared plus 2AS. And the fourth one, S is equals to UT plus half AT squared. Note, V, we call it what? Final velocity. U, we call it initial velocity. Then our S is equals to what? The distance or displacement. Then our T is equals to the time taken in seconds. Our displacement in meters. Initial velocity in meters per second. Final velocity in meters per second. Those are the units. Then I think I've taken all the parameters there. Then our A is equals to what? The linear acceleration, which has a unit of what? Meter per square seconds. So these are the 4 basic equations of what? Our linear motion. Let's now look at the application of these equations. For example, let's say a car moves from rest with an acceleration of 0.2 meters per square seconds. Find its velocity when it has traveled a distance of 50 meters. I repeat again, a car starts from rest and moves with an acceleration of 0.2 meters per second. Find the velocity after it has traveled a distance of 50 meters. Let's bring out the parameters. From the question, the acceleration is 0.2 meters per square seconds. The distance or displacement is 50 meters. The initial velocity, U, is what? 0. We have to find the final velocity. So you now look at these 4 parameters and you look at the 4 equations of motion. Which of the equations align with these parameters? Let's look at equation 1. Here there is no time. If you look at equation 2, it also involves time. There's no time in the expression. But if you look at equation 3, all the parameters here are here except what v, which conform with that. So it means we are going to use what? This third equation of motion. That is, from what we have there, it means that we have v squared is equals to u squared plus 2as. Our final velocity, that's what we have to find. Initial velocity is 0 squared plus 2 times the acceleration is 0.2 meters per second, and the displacement is what? 50 meters. So if you calculate this by our calculation, this is 0.2 times 50 will give us 10. 10 times 2 will give us 20. 20, then you take the square root of 20. Therefore, v is equal to the square root of 20, which is same thing as square root of 4 times 5. Square root of 4 is what? 2. And that gives us 2 root 5 meters per second in third form. So this is the velocity. That is what? This is the final velocity. Now, another thing you need to take cognizance of is that sometimes this velocity may be expressed in kilometers per hour, and you'll be asked to express your answer in meters per second. How do you go about that? It is very simple. Let's look at this scenario. Now, assuming that you have to convert a velocity of, let's say, 10 kilometers per hour into meters per second. How do you go about this? It is very simple analogy. You know that here kilometers and meters are involved, hours and seconds are involved. So if you look at the kilometer, you know that 1,000 kilometers is equivalent to 1 meter is equals to 1,000 kilometers is equivalent to what? 1 meter. Likewise, 3600 seconds is equivalent to what? To an hour. So if you are converting 10 kilometers to meters per second, it is very easy. Just multiply by 1,000 divided by 3600. So therefore, our 10 kilometers per hour in meters per second is going to give us 10 times 1,000 divided by 60 times 60. That is what? The conversion in meters per second. And if you do this, we have zeros, 0, 0, 0, cancel 0. Remaining what? 100 over 36 meters per second. So this is the conversion. How you convert from kilometer per hour to meters per second. So in case the question appear in kilometer per hour, don't panic. This is the simple way in which you convert your answer to meters per second. That now takes us to what? The motion under gravity. The application of the linear motion is what I just explained now. But before I move to motion under gravity, let's take another example. Assuming a body is moving with an initial velocity of 2 meters per second and attain a what? A final velocity of, let's say, 5 meters per second in what? In time, let's say 0.2, or let's say in time 60 seconds. In time 60 seconds. Then we have to find 1, the acceleration A, and 2, the distance covered. The distance covered within this period. How do we go about it? We still base our solution on the 4 equation of motion. Let's look at the parameters given to us. Initial velocity is 2 meters per second. That means it's not starting from rest. The final velocity is 5 meters per second. The time taken is what? 60 seconds. And we are asked to find what? The acceleration A. We also have asked to find the displacement ds. So if you look at these 4 parameters from our equation of motion, you see that what? The first one that conform with this is equation 1 of motion, which states that v is equals to u plus at. Look at the parameters. Final velocity is given. Initial velocity is given. The time is known. We are looking for the acceleration. So from these parameters, let's substitute. It means we have 5 is equals to initial velocity is 2. Acceleration is what we are looking for. And the time is what? 60. So if we subtract 5 minus 2 is equals to 60A. 5 minus 2 will give us what? 3. 3 is equals to 60A. Divide both sides by 60. So therefore, our acceleration is equals to 3 over 60, which is given as 1 over 3 in 60 is what? 20. So you can leave it as 1 over 20 meters per square seconds, or 0.05 meters per square seconds by calculation. So this will be what? The acceleration of the body. Then the other one, we have to find what? The displacement or the distance covered. You can use any of the formula because we have all the parameters here. So using our equation, S is equals to ut plus half at squared. Remember I said you can use any of the equation. The time is known, the initial velocity, the acceleration is known. We have S is equals to initial velocity is 2, the time is 60, plus 1 over 2 times the acceleration is what? 0.05, and the time is what? 60 by 60. So when you do this calculation, we are going to have S is equals to 2 times 60 is 120, plus 2 in 60 will give us 30. That is 0.05 times 30 times 60. 1, 2, 5. So we have 3 times 5, 15. Then 15 times 6. 6 times 5, that's 30. 6 times 6 plus, that's 90. So our S is going to be what? 120 plus 90. That gives us what? 210 meters. So that will be what? That will be the distance covered by the body. Okay, so let's now move toward the motion under gravity, which is another concept under our equation of motion. Now, when you talk about motion under gravity, you will have had a scenario that when you throw an object up, it will definitely come down. Yes, that is true, but that is only under some circumstances. There are circumstances where you throw an object up, it will not come down, but it will proceed into the atmosphere, into the sky. So, but what we are looking at is what? Motion under gravity. That means motion under the influence of gravity. And when we talk about gravity here, we also call it acceleration due to gravity. Acceleration due to gravity. In other contexts, we call it acceleration of free fall. Acceleration of free fall. Whichever one you come across, we are still saying the same thing. And it is represented with small letter G. And the unit is what? Meters per square seconds. Now, when you talk about motion under gravity, we have two scenarios here that I'm going to paint here. The first one is what? If an object is ascending, that it is the object here. Ascend means what? It is moving upward. That's the first scenario. Motion under gravity. If an object is ascending, that's moving upward. The second scenario is what? If an object is what? Descending or falling. Now, these two scenarios, when an object is ascending, then the object is what? Is working against gravity. And when you say something is against, it means what? It is opposite. That is negative. So here we are going to have negative gravity. But if an object is dropping, for example, a fruit falling from a tree, from the top of a tree, that is what? An example of what? A body what? Coming down. And in that case, the body is working in consonant with gravity. In that instance, we have what? Our G as what? Positive G. Now, all these equation almost is still applicable. Now, if a body is at rest here, and you are projecting a body upward, the initial velocity is 0. So when you are projecting the body upward, the velocity will be increasing, or it gets to a peak. At this maximum here, which is the peak here, your final velocity is 0. But in between, the velocity is what will be increasing. So when you project an object upward, the velocity will be increasing, or it gets to the peak. At the peak, your final velocity becomes 0. Likewise, when you drop an object from the top, here, the body is at rest. As the body is going down, the velocity will be decreasing until you get to what? Final velocity, which is what? At the ground here. So at the ground level here, the velocity is what? Is 0. But at the peak also, when the body is at stationary point, the velocity is also 0. So for this one here, I'm going to combine the two equations using our equation of motion. Now, for an object ascending, that is moving upward, we are going to have V is equals to U minus GT. Remember our equation of motion. U is equals to what? V is equals to U plus AT. But because it's under gravity now, that A will change to G. Now, also since it's moving upward, it's going to be what? Minus G. Likewise, if the body is dropping, then we are going to have V is equals to what? U plus GT. Because it's what? It is in consonant with gravity. That's the first equation. Secondly, we also have our S, but here since it's gravity upward, we change this one to H is equals to UT plus minus what? Half GT squared. And likewise for the other, I have what? H is equals to UT plus half GT squared. Then for the third one, I have S is equals to, I have the third one, V squared is equals to what? U squared minus 2GH. And here I also have what? V squared is equals to U squared plus 2G. So whichever one you have here, it depends on what, how the object or how the body is what is moving. So let's look at one scenario. For example, our H for using this formula at the peak here, our H, that is the maximum height for this object that is projected upward. We call it H maximum. At the peak here, since the velocity is 0, we are going to have what? 1 over 2 gt squared, because the initial velocity is going to be what? 0. Because it is what? Is it not horizontal motion? Likewise, if you use the other one here, we are going to have what? V squared is equals to what? 2gh. And which, if you make h the subject, we are going to have what? H is equals to v squared over 2g. This is likened to what? Your projectile motion. But remember that what we have here is what? Is our final velocity. So it depends on if the body is dropped or the body is what? Projected upward. That determines the formula to use. But never make that mistake. The important thing is what? Understand the concept that when the body is projected upward, everything will be negative. When the body is released from the height, everything will be what? Will be positive. And all the parameters still remain the way they are. I hope you understand all this explanation. In our subsequent classes, I will put more light into it, and I will come with more examples or the application so that you really understand how you can apply this when a body is dropped from an height and when a body is projected. Thank you.